Hello guys and welcome back to my channel Aviation Mentors. Guys, in today's video what we are going to do, we will be starting the topic of convergency. So this is a very scoring topic which comes in the DGC examination and very easy to understand. But most of the students find it difficult to understand the concept of convergency. So I will try to keep it simple so that you guys can understand, and I will try to make 2 to 3 videos of this topic to divide this topic in 3 parts, which includes numerical as well. So first we will try and understand the concept of convergency. So first of all, let us write down the definition of the convergency, and then I will explain you what do we mean by the convergency. So guys, very simple. Okay, so we are gonna go step by step. So first of all, what is convergency? Convergency is nothing but defined as the angle of inclination between the two meridians. So I'm not gonna make it write down the full definition, but I'm gonna write down the keywords for you. So it is the angle of inclination. Okay, the angle of inclination between the two selected meridians over a particular latitude, at a given latitude or a particular latitude, given latitude. Now, guys, let us understand what do we mean by this definition, angle of inclination between the two meridians at a given latitude. So let's just do one thing. First of all, we will select two meridians. So now, as you can see, I have already put up a picture of a graticule. So what I'm going to do is I'm going to take a different color and mark two two longitudes, okay, or the two meridians. So let us take one meridian, this one, and with the same color I'm gonna take up a different one. Now let us just assume that this meridian will be your 40-degree west meridian and this one will be your 40-degree east meridian. Now if we want to check the angle of inclination between these two meridian, that angle of inclination will be your convergency. But very important point that you should remember, convergency is not just the angle of inclination between the two meridian, it is also about which latitude or which parallel of latitude you are taking to calculate that particular convergency. For example, first case we will take case 1, we will take equator. Equator is a great circle as well as your rhumb line. Rhumb line, why? Because it acts as a parallel of latitude. So to know more about the great circle and rhumb line, you can always refer to my previous videos, and please do comment on the video what more do you want out of the video, like any particular topic or the questions or anything that you don't get. You are always welcome to comment in the comment box and I will try and answer the question. Okay, so let us continue. So case 1 is we will be taking at the equator that what is the convergency. So guys, just have a look. I'm going to take up a different color, let's say purple. So if I take at this particular latitude or the equator, we can see if I draw the tangent, this color is actually mixing up with the blue. So let me take yellow. So if I draw a tangent at the equator at the two meridians, 40-degree west and 40-degree east, you can see that these meridians are parallel. See, these meridians are parallel to each other. Parallel to each other. So if you draw a tangent, so let me explain you here. So if this is the circle, if this is the earth, and if I take the equator, this is the equator, and you draw a meridian. So this is joining the North Pole and the South Pole. North Pole, South Pole, North Pole, and South Pole. So if you draw the tangent at the equator on the two meridian, they will be parallel to each other. They will be parallel to each other. And what do we mean by parallel to each other? That they are not converging. वो मिल नहीं रहे हैं, वो इंक्लाइन नहीं कर रहे हैं एक दूसरे पे. अगर हम लोग इक्वेटर की बात करते हैं, इफ वी टॉक अबाउट इक्वेटर, these meridians they are not converging. So what we make out of this? We can say at equator, at equator, convergency between two selected meridian, whatever meridian you select, they will always be parallel at the equator. At equator, convergency between two selected meridians will be zero. It will be zero. Okay, very easy to understand. You can see at the equator. Okay, for example, you take this one and the outer one. All meridian, if you draw the tangent to all the meridians at the equator, they will be parallel to each other. You will feel that they are not converging. They are not converging, and hence the convergency at the equator is zero, because the definition states that the angle of inclination between the two selected meridians. So there is no angle of inclination because the meridians are parallel. They are parallel at the equator, and hence there is no angle of inclination, so the convergency is zero. Okay, so guys, before I move up to the poles, I want to explain you one more thing. Now have a look here. Okay, let's just copy this one, this diagram. Okay, now have a look. Before I'll explain you what happens at the pole and the mid latitude, let us see one thing. So now, if you look at this figure, what we see is that all the meridians converge as they run towards the nearer pole. So I'm going to draw, let's just assume this one is the equator, this red line. Okay. Now, we can see that all meridians are converging towards the nearest pole. All meridians, they are converging. They are converging where? They are converging towards the pole. Okay. And they diverge as they run away from the nearer pole. So, first of all, I'm going to write it down for you so that you can make the notes. Okay. So, write down. So, meridians, you can write along with me and make notes. So meridians are great semicircle. Okay, they are semi-great circle. And the important point what I'm telling you is meridians converge. Meridians converge as they run towards meridian converge as they run towards the nearer pole. When they come to the nearer pole, they converge and diverge as they run away from nearer pole, as they run away from nearer pole. So what do we mean by diverge? So let me just gonna quickly draw for you. Okay, so this is the earth. So what I'm gonna do is I'm not gonna draw the complete graticule. I will just take two meridians. So let me just take two meridians. Okay, so this is north, this is south, this is north, this is south, and this is equator. So see, when we are meridians converge, so as they are going towards pole, they are converging. They are converging. Now as you move away from the pole, see, I am moving away from the pole. When you move away from the pole, they diverge. See, I am moving away from the south pole. These two meridians, they are diverging. Okay, so this is the simple thing that will make you help the topic of convergency, that when you go towards the nearer pole they converge, and when you move away they diverge. Simple. Now let's just talk about the convergency at the pole. So we have seen what happens at the pole. So what I'll do is I'll make a picture, and now this is a top down view. Okay, so consider this, that you are viewing the earth from the top, from the north pole. So if this is the north pole, this is the north pole, let us draw the meridians. Suppose this is the meridian, these are all meridians. So I'm going to draw the meridians. So the all meridians, they converge at the poles. They converge at the pole. So let us see what will be the convergency at the pole. Let us see. Okay. So these are the meridians, and let's say this is your north pole. This is the north pole. Now, guys, the diagram is not that accurate. So just for your understanding, my drawing is not that great. So these are all the meridians. So if you look at the earth from the top, you will have a view like this. So now let us take two meridians. Okay, so I'm going to take up a different color. Now let us take this meridian and this meridian. Now if we take these two meridians and if we draw a tangent, so we can see this will be the convergency at the pole. And if you look at the diagram very carefully, the convergency is nothing but the change of longitude at poles. I'm going to tell you again, don't get confused. Okay, if you observe the earth from the top point, this will it the earth will look like this. Okay, so all the meridian converging towards the pole. So अगर ध्यान से देखो, अगर इन दो meridians के बीच में, if I have to take convergency इन दोनों meridians के बीच में, so what will be the convergency? It is nothing but the change of longitude. So if this is 40° west and this is 40° east, so this will be convergency is nothing but your 80°. Very simple. Now let us see. Let us prove it from a different point of view. So I'm gonna take up. Okay, so we can take up this one. Okay, now have a look here. Guys, have a look. If we talk about the poles at the equator, we see they are parallel. But if you talk about the if you talk about the poles, see at the poles at the poles means at the 90° parallel of latitude or closer to the pole, you will see that the convergency is nothing. If you draw the tangent, if you draw the two tangents like this, so it will nothing but your change of longitude. Change of longitude. Okay, now guys, if you draw the tangent nearer to the pole, so for example, I'm going to draw a tangent and we'll have a look. See, if you draw a tangent, I'm going to draw a tangent to this, and I'm going to try and draw a tangent to this latitude, this meridian, sorry. Okay, longitude. So if you draw tangent to these two meridians, you will see that it represents nothing but the change of longitude. Change of longitude. Okay, so, what we have seen so far, at the equator, the meridians or the longitude are parallel to each other. So, the convergency was 0. And as we move towards the pole, at the pole, it is nothing but the change of longitude. Now, the question arises, sir, what will be the convergency in the middle latitude? Okay, so that is what our concern is. What will happen at the middle latitude? Okay, so now so far let us summarize what we have seen. We have seen that at equator the meridians or the longitudes, they were parallel. So the convergency was what? The convergency between them was 0. And at poles, at poles, the convergency was what? It was the change of longitude. Now let us talk about the mid latitude. Now have a look here. Now we will derive what will be the convergency, and we will also talk about why this convergency is important, why we are studying it, why we are using a brain to study what convergency is. We will also understand that. So now what I'm going to do is I'm going to draw two longitudes for you. This one, okay, the drawing is not that great, so please just ignore the drawing, just understand the concept, that is important. Okay, so what I'm going to do, I'm going to take up a parallel of latitude. So now let us say This is 30-degree north parallel of latitude. This is my north, this is my south. Now I have to find out the convergency between these two meridians. So let me say this is 40-degree west and this is 40-degree east. Now दो meridians हैं, एक 40-degree west का meridian है and the other meridian that we have is 40-degree east meridian. Now if we have to find out the convergency at the 30-degree north, तो अब वो कैसे निकालेंगे? सिंपल है, tangent ड्रॉ करना है. वी हैव टू ऑलवेज ड्रॉ अ tangent. So if I draw a tangent here, okay, this is the tangent. See again the drawing. Wait. Okay. Okay. So this is the tangent. Perfect. Okay. So this is the tangent. Now what I'm going to do is I'm going to draw another tangent to the 40-degree east meridian. Okay. I'll draw another tangent to the 40-degree east meridian. So let us draw the tangent. Okay. This is the tangent. So let me just correct this. Okay, I have to incline this a little. Okay, so this is the tangent. Now, guys, to find out the angle of inclination between the two meridians, which is the 40-degree west and 40-degree east meridian at the 30-degree north, 30-degree north parallel of latitude, what I'm going to do is I'm going to take this. So let us say this is x. Okay, this is x and this is y. So what I'm going to do is I'm going to take this tangent and take it here. Okay, I will superimpose this one. You can see. Okay, so now whatever the angle this makes, okay, what I'm going to do, I will highlight this by yellow. So this yellow angle is known as your convergency. This will be convergency at the 30-degree north parallel of latitude. Okay, so by superimposing the tangent, see this tangent was here. So when this tangent was here, this tangent was representing the angle. Okay, this tangent was representing the angle of inclination of 40-degree west meridian on the 30-degree north parallel of latitude. So simply I took this tangent to the y, means the 40-degree east meridian, and put it here. So whatever the angle these two tangent make will be my convergency. Okay, so this is how we find the convergency. Now guys, what is the convergency? Okay, so now we have understood that it is the angle of inclination and we can use the tangent principle to find out the angle between the two meridian. Okay, now what is the formula? Now what is the formula for the convergency? Now see, convergency at the poles, if you talk about the poles, it was the change of longitude. Okay, at the equator it was 0. So it was minimum at the equator and maximum at the poles, right? And in the middle latitude, let's say 40-degree north, whatever, in the middle latitude between the equator and the pole, it will be in between the Shillong and the 0, which is the minimum value. Now we need a function. Okay, so now the convergency formula is what? Chi long, change of longitude, into multiplied by sine of latitude. Now you need to understand why we have taken the sine of latitude, because the sine function does a job. Does a job means if we take sine 0, it is 0. Sine 90, sine 90 is 1. So the sine function is absolutely doing the job for us. Why? Because at the poles, where the poles we will take theta as 90 degree, it is maximum. The convergency is maximum. So if in the convergency formula, जो ये convergency का formula है हमारा, उसमें अगर मैं poles पे लेता हूं तो शीलोंग इंटू साइन 90 लूंगा. साइन 90 की वैल्यू कितनी होती है? साइन 90 की वैल्यू होती है 1. तो साइन 90 की वैल्यू 1 होगी तो कन्वर्जेंसी पोल्स पे होगी शीलोंग. परफेक्ट है, शीलोंग ही होती है. हम लोगों ने टेंजेंट ड्रॉ करा था एंड वी हैव सीन दैट इट वाज द शीलोंग. Now equator पे let us check out at the equator. Equator पे the theta will be 0. So Shillong into sine 0. Sine 0 is 0. So convergency is 0. It is 0. Okay, because the meridians were parallel at the equator. Okay, now at the middle latitude, let's suppose you are taking at the 30-degree north latitude. So theta will be 30. If you take at the 45, you will take theta as 45. If you take at 70, you will take it 70. And you will get a value which is in between the minimum and the maximum. That is why we have used the sine function. Okay. So this is the first step. First step is to know your formula. So formula is convergency is equal to change of longitude into sine of latitude. And please guys, don't get confused. I'm explaining you again that convergency is nothing but your inclination of meridians. Okay, so if this is the equator, this is the middle latitude, and this is the pole. If I draw meridian, let's say, let us just draw one meridian. Okay, here is the meridians. This is north south. So if I draw tangent at the poles, they are parallel in it. If I superimpose this meridian to here, do you see any convergency? No. That's why at equator we say convergency 0. Now let's just try with the middle latitude. This is just a revision, okay? So if I draw this tangent here, if I draw this tangent here and I draw the another tangent here, this is the other tangent. Okay, let me just correct this one, the position. Okay, and this tangent comes out here, and if I superimpose this, so middle latitude, what will be the convergency? This will be the convergency, okay, which is you can find out by this formula. And at the poles, if I draw the two tangents, if I draw two tangents at the pole, so this would be the one and this would be the one. So they will, if I superimpose this, if I superimpose this one, sorry, let me just correct this. The drawings are not that great, okay, so just avoid. So if I superimpose, I will see that this angle will be nothing but my change of longitude. And this you can clearly see through the diagram of the gratitude, that if you take at the equator any two longitude, it will be nothing but the change of longitude, because if I draw tangent, it will superimpose at the change of longitude, so the angle will be change of longitude. So this was your convergency. Okay, this is the convergency, angle of inclination of meridian. So जो हमारे मरीडियंस होते हैं वो इंक्लाइन करते हैं, बट डिपेंड करता है आप कौन से लैटिट्यूड पे उनको देख रहे हो. ठीक है. सो कन्वर्जेंसी इक्वेटर पे 0 है, पोल्स पे मैक्सिमम है, एंड मिडिल लैटिट्यूड में हमने इस फॉर्मूले से फाइंड आउट करनी है. ओके, नाउ यू नीड टू रिमेंबर वन थिंग, दैट कन्वर्जेंसी जो है, ओके, इट डिपेंड्स अपॉन योर लैटिट्यूड. आप कौन से लैटिट्यूड में उसको मेजर कर रहे हो, दैट इज वेरी इंपॉर्टेंट. ओके, दिस इज वेरी इंपॉर्टेंट कि कन्वर्जेंसी कौन से लैटिट्यूड पे आप मेजर कर रहे हो. अच्छा, ना अब अंडरस्टैंड करते हैं कि ये कन्वर्जेंसी का कॉन्सेप्ट आया कहाँ से और इसको हम लोग यूज किधर किधर करते हैं. ओके, सो अब मैं क्या करूंगा, मैं अब एक ग्रेट सर्कल ट्रैक को ड्रॉ करता हूं. ठीक है, ग्रेट सर्कल ट्रैक हम लोग ड्रॉ करते हैं. तो उसको ड्रॉ करने से पहले एक चीज हमेशा याद रखना. क्या याद रखनी है? कि रम लाइन ट्रैक होता है. योर रम लाइन ट्रैक, what is rhumb line track? Rhumb line track is a constant true direction track. Understood? तो जब whenever we travel on a rhumb line, what is a rhumb line track? Rhumb line track is a constant true curve. Okay. So rhumb line, I will write it down for you. Rhumb line cuts, rhumb line track, you can say rhumb line or rhumb line track cuts all meridian at an equal angle. It cuts all meridian at an equal angle. So it is a constant true direction track. It is a constant true direction track. Whereas your great circle track, GC track, great circle track क्या करता है? GC track cuts all meridian at a different angle. Okay, not a constant angle. It cuts all meridian at a different angle. अब उसको समझ लेते हैं एक बार. We'll draw a picture and then we will understand. So suppose let us just draw a earth. Then what I'm going to do, I'm going to draw a equator. This is the equator. Now let us draw north to south, this one meridian and this the other meridian. Okay, so let us just label this is north, this is south. We have drawn the equator as well. Now, what I'm gonna do is I'm gonna draw one GC track. Let us just draw one GC track. So, suppose this is my GC track. Okay, this is the great circle track I have drawn. Okay, I have to take, let me just draw it again. This is the GC track. Okay. Now, the great circle track, as we have seen in the definition, the great circle track cuts all meridian at a different angle. Okay. So, this will cut this meridian at what angle? So, I'm going to take it with the blue color, this one. Okay. This angle. And इधर कौन से एंगल पे कट करेगा with the other meridian? This will cut at the this angle. So, you can say if this angle, say let's just say this is angle A, this is angle B. So जो great circle track is making angle A with this meridian. Okay, let's say that this is meridian X and it is making angle B with the meridian Y. Okay. Now I'm gonna rub this and we're gonna find out the convergency. Okay, we're gonna find out the convergency कि convergency कैसे role play कर रही है between the great circle track. Alright, so convergency के लिए सबसे पहला step क्या है? What we are going to do? We will be drawing out the tangents as usual. So let us just draw the tangent. Okay, this is the first tangent that I have drawn. Okay, so let me just correct this. Perfect. This is the tangent number 1 and let me draw the angle. This is the angle A. So just to give it a better look, what I'm going to do, I'm going to take a blue color marker and let me just mark this with a dark color. So this is the angle A. Now what we'll do is we'll draw a second tangent on the meridian. So this is the second tangent. Okay, so perfect. This is the second tangent. Now this second tangent is making angle B. It is inclined at an angle B. So now what we are going to do is we will take this tangent which is making with meridian X. So let me write down for you. This is X meridian, Y meridian. So X वाले meridian का tangent को उठा के मैं Y वाले meridian पे ले जाता हूँ. ओके, Y वाले meridian पे मैं ले जाता हूँ. सो अब नाउ वी नो अगर tangent में इधर लेके गया तो मेरा एंगल ऑफ इंक्लिनेशन जो है जिसको मैं कन्वर्जेंसी बोलता हूं, that the angle of inclination will be represented by, let's just take the yellow color, this one. This is what? Convergency. Convergency. Now guys understand, this is your convergency. So how much your great circle track has changed, how you gonna get it? Okay, so the difference of the angle between the two. Now understand, I know this can be confusing, but this is not confusing at all. So this is the convergency. So if I say the difference between the two great circle track, so if I take B, so see this is the angle B, the red one is angle B. Okay, now this is angle A, this is angle A. So if B minus A, now B minus A gives you convergency. B minus A gives you convergency. So the great circle track changing direction can be found out by the convergency. Okay, by how much your great circle changes the direction can be found out by the convergency. Now flying all your flying system, like your inertial navigation system, inertial navigation system, your GPS, global positioning system, your flight management computers, they all fly the great circle track. Now, to find out they all fly the great circle track. So all these convergency information is being loaded into the computer, so they can calculate precisely that how much my great circle track will change when I cut across the other meridian. Okay, सो सिंपल है, यहां से देखने में ही पता चल रहा है ये टैंजेंट का एंगल था बी, जो कि वाई मेरिडियन के साथ था, जब ये वाला टैंजेंट जो एक्स का टैंजेंट है ये एंगल बना रहा था ए, जो कि ये सेम एंगल है। तो जो बी माइनस ए था वो कन्वर्जेंसी था, दैट वाज माय कन्वर्जेंसी। तो चेंज ऑफ ग्रेट सर्कल ट्रैक इज योर कन्वर्जेंसी। इसीलिए we study the convergency, that is the reason we study the convergency, because जो great circle track change होता है that is being given by the convergency. So I'm going to write down the definition, so the student who are studying for the DGC examination they can write down the definition. Okay, the change in great circle track direction, the change in great circle track direction is the angle of inclination of the meridians at the 2 points where the track is measured. So simple. I'm going to read down the definition for you again. The change in great circle track direction is nothing but the angle of inclination of the meridian at the 2 points where the track is measured. So we are measuring track at which point? We are measuring at this point, and we are measuring at which point? We are measuring at this point where the great circle is cutting the x meridian and the y meridian. So जो दो पॉइंट्स पे ग्रेट सर्कल कट कर रहा है एक्स मेरिडियन एंड वाई मेरिडियन को, उसमें जीसी ट्रैक कितने से चेंज हो रहा है? बाय दी कन्वर्जेंसी। सो दो, अब आई एम गोना एक्सप्लेन दिस डेफिनेशन इन हिंदी एज वेल एज इंग्लिश। ओके, सो जो एक्स और वाई के बीच में कन्वर्जेंसी है, तो जो भी ग्रेट सर्कल एक्स और वाई मेरिडियन को कट करेगा, तो एक्स मेरिडियन पे उसका ट्रैक होगा ए, और वाई मरीड जब वो कट करेगा हमारी वाई मरीडियन को, तो उसमें ट्रैक कितना होगा? उसका ग्रेट सर्कल ट्रैक कितने से चेंज होगा? उसका ट्रैक होगा बी, और वो चेंज कितने से होगा? बी माइनस ए। तो अगर मुझे पता है कि मेरा एक्स मरीडियन पे ट्रैक है 30 डिग्री फॉर एग्जाम्पल, और मुझे पता है मेरी कन्वर्जेंसी बिटवीन द एक्स एंड वाई मरीडियन है 20 डिग्री, तो मेरा ट्रैक एट बी कितना हो जाएगा? 50 डिग्री। इसीलिए कन्वर्जेंसी पढ़ते हैं। समझ आया? आई होप यू गाइज अंडरस्टैंड। ओके, इफ नॉट यू कैन कॉमेंट एंड आई विल एक्सप्लेन इट अगेन फॉर यू गाइज। Okay, so this was the convergency. Now what happens is, guys, have a look, very carefully look at this. So I'm gonna explain this definition again in English. So at the x meridian, now you can write down also, at the meridian x, my great circle track was angle A. It was angle A because my meridian x was making angle A. Okay, my great with the great circle track. Now my great circle track at meridian y was angle B. Now if I want to calculate how much is my great circle track at meridian y, all I need to know is the convergency between the meridian x and meridian y. If I know the convergency, I just need to put the convergency and I can get the great circle track at the meridian y, because the great circle track of meridian y minus the great circle track of the meridian x gives me the convergency. So that is by how much my great circle track changes. Okay, so this is the formula we use. Now let's just go ahead, and I'm gonna explain you one more thing. Now in this question, in this particular question, if you have a look at it, the great circle is, we are not traveling on a particular latitude, so our latitude is changing. If you go ahead and have a look at this formula, which is the convergency is change of longitude multiplied by the sine of latitude. So this formula we have used when we are traveling on a same latitude. But here if you have a look, we have a different latitude. If this is the latitude, you're traveling when you are at the point on the meridian x, when you are traveling, this is the latitude, and this is the latitude when this is the parallel of latitude which cuts the meridian y at this point where the great circle track is there. So now the question arises, which latitude you will be taking in the formula? Will you be taking this parallel of latitude as the theta, or you will be taking this parallel of latitude as theta? So guys, when these kind of question come, what we do is we use the formula that convergency is change in longitude, change in longitude multiplied by your sine mean of latitude, sine mean of latitude. What do we mean by mean latitude? We take the average between the two latitude. For example, let's just say this was the equator and this is the 30-degree north. So we'll take the average. So the average comes out to be 15-degree north. Okay, so we will take the 15-degree north. Understood? So if the case like this come, we'll take the mean of latitude. Mean of latitude means the average of the latitude we will take. So this was all about your convergency. So in the next video, what we're going to do is we will be discussing about the convergent angle. Okay, and how to derive the convergent angle and what is the convergent angle. And then in the third part, we will be discussing about all the numericals which comes in your DGCA examination. So let's just, before I end the class, I'm going to summarize the above topic for you. Okay, very quickly I will do it because the video has already gone too long. So guys, have a look at this. This was the this okay this has okay, let me join this and this. Okay, so this is north, this was the south. Okay, and let's just say I'll draw one great circle track. So let me just draw a great circle track. This was my great circle track. Guys, the great circle track, this is the meridian x, this is the meridian y. Great circle track cuts the x meridian. So अगर if I want to calculate, अगर मुझे पता लगाना है कि x पे जहां ये पॉइंट को कट कर रहा है उस पे ग्रेट सर्कल ट्रैक कितना था, तो दैट वाज a, और y पे कितना था, दैट वाज b, and the difference between the two great circle track gives me the convergency. Okay, it gives me the convergency. How? वो हम tangent लेके ले सकते हैं. So if this is the tangent, okay, I'm doing it quickly because I will be ending up the video because it's already been too long. Okay, so this is the tangent and this is the tangent. This is the tangent. Let me just correct this. Okay, so this is the tangent. So if I superimpose this tangent out here, okay, let me just correct this one. Okay. So if I just again, wait. So if I just take this and superimpose here, so whatever the angle, so this angle here in the picture is very small. So this angle, so this will be nothing but your B minus A. So B minus A, the change of the track of the great circle will give you the convergency. So I hope you guys have understand what the convergency is and how the formula is derived. So you can watch this video again and again, note down the points, all everything that I have explained. This is just I have talked about convergency today. In the next video, what we are going to do is we will be talking about the convergent angle. Okay, what is the convergent angle? And in the part 3 video, we will be solving the numericals. Okay, so I hope you guys have liked the video, and if you like the video, do share it with your friends and like and subscribe my channel. Thank you so much.